See, yeah. So how we have defined the left hand limit is limit x tends to c minus of f of x, or this is also defined as x tends to 0. Limit x tends to 0 of f of c minus h. Note this, c minus h is slightly less than c. So if this is c minus h appears here. To the right side of c, you get c plus h. And what is RHS, right hand limit? Limit x tends to c plus of fx, which is limit x tends to 0 f of c plus h. You define now f of c plus h. Okay, from the last discussion, suppose I have to get this. Limit x tends to 4 minus of the greatest integer x. We can write this. Limit x tends to 0 of 4 minus h. Okay, see that this is 4. 4 minus h appears to the left side of 4. 4 plus h is to the right side of 4. 4 minus h means which is to the left side of 4. What is the greatest integer? Greatest integer which is less than 4 minus h. Definitely it is 3. If 4 minus h ಗಿಂತ ಕಡಿಮೆ ಇರೋ greatest integer ಯಾವುದು 3. Limit x tends to 4 plus, that is limit x tends to 0 of 4 plus h. Nodi 4 plus h. 4 plus h is greater than 4. What is the integer which is less than 4 plus h? Greatest integer less than 4 plus h. ಅಂದ್ರೆ ಯಾವುದು ತಗೋಬೇಕಾ 4. ಇದನ್ನೇ ನಾವು ಜನರಲೈಸ್ ಮಾಡಿದ್ರೆ ಲಿಮಿಟ್ x tends to c minus of greatest integer. Limit x tends to 0 of c minus h. Greatest integer which is to the left side of c minus h. Okay, suppose x equal to c. Remember, it is integer. The integer which is to the left side of c is c minus h. So the left hand limit is always c minus h. And to the right side, limit x tends to c plus of greatest integer x. That is limit x tends to 0 of c plus h. Okay, now c plus h is here somewhere, c plus h. What is the greatest integer which is less than c plus h? Is c. So left hand limit is c minus 1, right hand limit is c. And one more one. If c is not an integer, suppose I take suppose c equal to say 1 point or make it 3.5. Okay, now 3.5. To the left side of that we have 3, to the right side of that we have 4. Now in the neighborhood of 3.5 we are checking. Okay, take the left hand limit. Left hand limit say x tends to 3.5u minus means of greatest integer x, or it is limit x tends to 3.5u minus a quantity which is slightly less than 3.5, say 3.49 you gave 3.4. Tell me, what is the greatest integer less than or equal to 3.49? 3.49 ಗಿಂತ ಕಡಿಮೆ ಇರೋ ಇಂಟಿಜರ್ ಅಂತ ತಗೊಂಡ್ರೆ ಮತ್ತೆ ಏನು ಬರಬೇಕು? 3 ನೇ ಬರಬೇಕು. So this is equal to 3. Equal to 3. Okay, this number is 3. This is 1. Okay. Now if we take the right hand limit x tends to 3.5 plus of greatest integer x. Limit x tends to 3.5 plus of slightly greater than 3.5. Say 3.51. What is the greatest integer less than 3.51? 3.51 ಗಿಂತ ಕಡಿಮೆ integer, greatest integer less than or equal to, greatest integer less than or equal to, ಇದಕ್ಕಿಂತ ಕಡಿಮೆ integer ಅಂದ್ರೆ ಏನು ಬರಬೇಕು? 3 ನೇ ಬರಬೇಕು. Okay, so when if we check at the point x equal to c and c is not an integer, c is not an integer. The example 3.5, this is not an integer. What is the left hand limit? 3. What is the right hand limit? That is also 3, because if I take 3.49, it's the greatest integer 3 to the right side of 3.5. So if I take 3.51, that is also 3. So left hand limit and right hand limits are equal. Okay, see this question. Find all the points of discontinuity of the greatest integer function defined by f of x equal to the greatest integer x, where greatest integer x denotes greatest integer less than or equal to x. This box denotes the greatest integer less than or equal to x. Okay, see how the function is defined. Okay, so the greatest integer of x, it is defined like that. It takes the value -2 if x lies between -2 and what? -8. Suppose that this is -1, this is -2. In between ನಿಮಗೆ ಯಾವುದೇ ನಂಬರ್ ಬರಲಿ, the greatest integer of that is always -1, and it is equal to -1 if -1 less than or equal to x less than 0. ಈ 0 ಮತ್ತೆ -1 ಗಳ ಮಧ್ಯೆ ಇರೋ 0, this is -1. ಇವುಗಳ ಮಧ್ಯೆ ಯಾವುದೇ ನಂಬರ್ ಬಂತ to the left side we get -1. It is equal to 0 if 0 x is greater than or equal to 0 but less than 1. Andre suppose this is 0 and this is 1. ಈ 0 ಮತ್ತೆ 1 ಗಳ ಮಧ್ಯದಲ್ಲಿರೋ ಯಾವುದೇ ನಂಬರ್ ಇದ್ದ ಗ್ರೇಟೆಸ್ಟ್ ಇಂಟಿಜರ್ ని ತಗೊಂಡ್ರೆ ಆನ್ಸರ್ ಏನು ಬರಬೇಕು? 0, like that. Okay, and it will be 1 if x is greater than or equal to 1 but less than 2. Between 1 and 2, between including 1 but strictly less than, and again barabeisa 1. Now we discuss the continuity of this function in two special cases. One is when x is equal to c is an integer, okay, so the function is defined for all x belonging to R, for every real number it is defined. Let c be an integer. See, in this case we are discussing at the point x equal to c. Let x equal to c, we are checking at x equal to c be an integer. We are checking at the point c. Left hand limit x tends to c minus of greatest integer x. give a value which is slightly greater than c, that is c minus h. Now what is your answer? C minus h. Okay, note here integer c. To the left side of it we get c minus 1. C minus h is somewhere here. Somewhere here. This is somewhere c minus h. And what is an integer which is less than c minus h? Less than c minus 1, less than c minus h, which is to the immediate left side of c. C ಗಿಂತ ಕಡಿಮೆ ಇರಬೇಕು, ಅದರ immediate left side ಗೆ ಇರಬೇಕು. ಯಾವುದು? c minus 1. RHL. Limit x tends to c plus. Limit x tends to 0, c plus h. C plus h slightly greater than c. And what is the integer which is slightly less than c plus h when c is integer? C integer iddaga c plus h is immediate left side ge baro integer yavada? C. So what is the left hand limit? C minus. What is the right hand limit? C. So definitely LHL is not equal to RHL. Function is discontinuous at x equal to c. What is that c? C is integer. So therefore the greatest integer function is discontinuous whenever x equal to c, where c is an integer. C ಅನ್ನೋದು integer ಇದ್ದ function is discontinuous. Okay. Suppose c be a non-integral real number. C be a non-integral real number. In that case, see what happens. So limit x tends to c minus of, that is limit h tends to 0, c minus h, and limit h tends to 0, c plus h. See what is happening here. Suppose I check at the point say 2.5. To the left side, other left side ಗೆ ನಾನು ಹೀಗೆ ತಗೋಬಹುದು 2.49. What is your answer? 2. To the right side, say 2.51. What is the greatest integer which is less than or equal to 2.51? That is also 2. And what is the greatest integer of 2.5? That is also 2. So this is nothing but c minus h. This is nothing but c plus h. This is nothing but exactly c. Okay, and exact value f of c is nothing but greatest integer of c. See, it is like this. Greatest integer of 2 minus 2.49, that is 2. Greatest integer of 2.51, that is also 2. Greatest integer of 2.5, that is also 2. So greatest integer of c minus h and greatest integer of c plus h, and that is also equal to greatest integer of c. All these three are equal when c is a non-integer, and c is non-integer. So by this, what is our conclusion? Andre in conclusion ಮಾಡಬಹುದು. The function f is continuous at all non-integer values. F is continuous at all non-integer values. Okay, you know the graph of greatest integer function. Okay, the graph goes like this. Between 0 and 1, here it is open. Okay, then this is the point 1, 2, 3, 4 on this side, then minus 1, minus 2. Okay, between 1 and 2, so closed circle, at 2 open circle. 2 open, at 3 it takes a jump, open like this. That means to the left side of 2, to the left, this is our y equal to 1, this is 1, this. Okay, this is 1, this is 2, this is 3, and this is minus 1. Okay, this is the line y equal to minus 1. Okay, dash ಬರೆದ್ರೆ ಅವು ಪಾಯಿಂಟ್ಸ್ ಲೈನ್ ಮೇಲೆ ಇಲ್ಲ ಅಂತ, ಓನ್ಲಿ ದಿಸ್ ಪಾರ್ಟ್ ಇದು ನೋಡಿ. ಈ ಗ್ರಾಫ್ ನೋಡಿದ್ರೆ ನಮಗೆ ಏನು ಅನ್ಸುತ್ತೆ, ಫಂಕ್ಷನ್ ಈಸ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್. ವೇರ್ ಇಟ್ ಈಸ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್? whenever x takes the value integer, at 1 ಅನ್ನೋದು integer, at this point it takes a jump, at 2 it takes a jump from 1 to 2, 3 ಬಂದಾಗ 2 ದಿಂದ 3 ಗೆ ಜಂಪ್ ಮಾಡುತ್ತೆ ಹೀಗೆ. So the function is discontinuous whenever x takes integer value. Integer ಇರಲಿಲ್ಲ, ಸಪೋಸ್ ಈ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಮಾತ್ರ ನಾನು ನೋಡಿದೆ, ಈ ಪಾರ್ಟ್ ಸಪೋಸ್ ದಿಸ್ is 2.5 ನೋಡಿ, to the left side of 2.5 or to the right side of 2.5, ನಾನು ಇಷ್ಟೇ ಪೀಸ್ ನೋಡ್ಬಿಟ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ದ ಫಂಕ್ಷನ್ ಈಸ್ ಕಂಟಿನ್ಯೂಸ್. ಇಷ್ಟು ಪೀಸ್ ನೋಡಿದ್ರೆ ಕಂಟಿನ್ಯೂಸ್. ಓವರ್ ಆಲ್ ಗ್ರಾಫ್ ನೋಡಿದ್ರೆ ಅದೇನು ಅನ್ಸುತ್ತೆ, ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್. ಓವರ್ ಆಲ್ ಇಟ್ ಈಸ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್, but it is continuous only at non-integral value. ಇದು ನೋಡಿ 2.5 it is and it is not an integer. If I take say 3.7, this is point 3.7, ಈ ಪಾಯಿಂಟ್ is surrounding ನೋಡಿ, so function is continuous. ಎಲ್ಲಿ ಇಂಟಿಜರ್ ಬರುತ್ತೋ ಅಲ್ಲಿ ಮಾತ್ರ ಅದು ಜಂಪ್ ತಗೊಳ್ಳುತ್ತೆ. So the greatest integer function, therefore this greatest integer of x is discontinuous for all integral values, of x. x integer banta adu discontinuous irutte, and it is continuous at all non integral values. Non integer itta continuous value. Okay, so what we have to know, the greatest integer function is discontinuous at all integral values and is continuous at all non-integral values. Remember this as the standard result. Okay, see this question, just one more question. Write the point of discontinuity of this box, greatest integer x, where x lies between -1 and +1. The greatest integer function where it is discontinuous. ಎಲ್ಲಿ discontinuous ಇದೆ ಅನ್ನೋದು ಹೇಳಿದ್ರು. ಏನು ಹೇಳಿದ್ರೆ, we know the greatest integer of x, this function is discontinuous at all integral values of x. Now we have to tell where it is discontinuous between -1 and +1. ಈ -1 ಮತ್ತು +1 ಗಳ ಮಧ್ಯೆ ಎಲ್ಲಿ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್ ಇದೆ ಅನ್ನೋದು ಹೇಳಬೇಕು. ಸೊ ಅಂಡ್ ವಿ ನೋ ದ ರಿಸಲ್ಟ್, ನಮಗೆ ರಿಸಲ್ಟ್ ಗೊತ್ತಿದೆ. ಇದು ಎಲ್ಲಿ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್ ಇರುತ್ತೆ, ಬಿಟ್ವೀನ್ when x is integer, between -1 and +1. ಈ -1 ಮತ್ತೆ +1 ಗಳ ಮಧ್ಯೆ ಇಂಟಿಜರ್ ಯಾವುದು ಬರುತ್ತೆ, 0. So therefore this function, that is the greatest integer of x, is discontinuous at the x equal to 0. See this, write the points of discontinuity of this. The greatest integer of x where x lies between -2 and 4. Tell me, between -2 and 4. Between -2 and 4. That this is 0, 1, 2, -1, -2. Okay, 3, 4. We have to check between -2 and 4. What are the integers between -2 and 4? is minus 1, 0, 1, 2. Therefore, the greatest integer x is discontinuous at this point. Minus 1, 0, 1, 2, and 3. 0 and 3. Now, see this. So that the function defined by g of x equal to x minus greatest integer of x is discontinuous at all integral points. Also state where it is continuous. Okay. To answer this, nothing. Note the result. If f is continuous and g is discontinuous. If f is continuous and g is discontinuous, then f plus g, f minus g, f plus g is discontinuous. F minus g is discontinuous at those points. Okay, now see this. X, this is a polynomial function, hence continuous. Okay, hence it is continuous. And greatest integer function, this is discontinuous when x is an integer and the same function, it is continuous when x is not an integer. When x is not an integer. Okay, now from this, x minus x, this is continuous and this is discontinuous. This f is continuous, g is discontinuous. What about f minus g? Definitely it is discontinuous. First function continuous ittu, second discontinuous ittu andre definitely it is discontinuous. Okay, and if f is continuous, g is continuous, then the sum of two continuous functions is always continuous. Okay, so from this, what to write? The function of x is a polynomial function and hence it is continuous everywhere. And greatest integer of x is discontinuous at all integers. So therefore this function f x equal to x minus greatest integer x is discontinuous at all integers. Remember this, at all integers. And what is this part? Also state where it is continuous. So the function, also this function, the function f x minus this is continuous where at all non-integral values. Non-integral values of x. X integer this becomes continuous. So again f is continuous, g is continuous, f minus g is continuous. Okay, this is continuous.